Yeah. Yeah. Good evening, guys. Yeah. Don't, yeah. You see, Deji. Anyway, it's Oga. So that's how they do. You understand? They pull your leg, they pull your neck, they pull everything, pull it. So you are getting used to it. Yeah. But one thing I learned from him is that you have to help him to help yourself. So, and that's what I've been learning from him. Yeah. Good evening once more. My name is Alao Kayode, and my other colleague is Alex Johnson. So this evening we'll be talking on version control, which is fully part of explaining CICD in full. So bringing us the CICD. So at the end of this topic, we should be able to understand one thing. What is that version control? And that why version control matters in software. Why does it matter in software? Thank God that is all we are mainly QA here because it's not, and this version control is not only done by QA, we BA does it, DA data analyst does it, and developer does it very much. So and then so we will be able to understand it better than when we are talking about when we are addressing the BA and that we are mainly dealing with PBIs. So now there are types of version control as well out there. You'll be able to know those types. And then what are the benefits of this version control? Why we are doing version control? So what are the benefits that we are having there? And then we should be able to identify popular version control system. And don't be this version control is what you and I have been doing in our own limited way, even before we come to uh, this QA quality assurance and testers job training. We have been doing it in our own little way, but we may not know that we are doing it, and we have been even peeping into it bit by bit. So can you please go to the next slide, please, Alex? Yeah. No, okay. Which one? No, no, yeah, that's it. Version control. Now, what is version control? Version control is also known as versioning. When you hear somebody saying versioning, it's the same thing as version control. Source control is the same thing. They are talking about the same thing. So it's just the practice of how you manage your source code. When we say source code, it means the primary codes through which you are doing your job before you begin to add to it, before you begin to modify it, before you begin to refactor it, also to say. So it's just how you are managing it so that no code will be lost in transition, or no code will just be looking everywhere in your system. You will not even find anything again. But there is a way you can manage it, which can even make you to be able your code to be secure. So, and also it entails you keeping detailed account of every modification that you made to your code. As many of us are working, when I saw our test environment that we are sharing the other time. So sometimes if you don't, if maybe you are too busy, you finish testing maybe one feature, you store it in your repository, and later on when you now continue in it, maybe you see one thing, this code is too big, it's too here and there, let me just put it together now. Yeah, let me just put it together. So then you put it, maybe you modify it, you put it together. So at every point that you are modifying it, you'll be able to keep it together. Also, version control helps you to ensure that these changes, you'll be able to track the changes you are making, and you'll be able to even reverse if that change is bringing any error into your system or everything. Maybe when you release, or when you put it in your repository, you'll be able to go there and pass it back and make it better. Next slide, please, Alex. Yeah, we have types of version control. This version control have types. that we are. So that there are types of version control that is out there. We have local version control that are local to you. So in that local version control that we have, it means that your codes will be stored locally in some files or in patches somewhere. So before you now begin to push it to a single version code in a database. You understand? But now when you put it in patches and then you put it in a single version code in a database, this is good, but there is danger aligned to it. The danger is that since that you have put everything together in one place, if there like in the code room, maybe in a master computer, if anything happens to that code room or the master computer, that means all your code is lost. But notwithstanding, at least you have been able to store it somewhere else. Then we have central version control. The central version control of the code is that means you put all your codes in a centralized repository that everything, or maybe Abimbola, everybody, Jeremiah, all of you just put your code together and you put it in a centralized repository. So in this area, users can be able to access the versions that are there, and users like all of you will be able to push and pull there are changes that you even need make to the or you changes that you think is needed to those codes, you'll be able to do that. But another thing again is that because it's centralized, and you put it in a centralized repository. So when anything happens to that centralized system, for you to be able to retrieve your code will be very difficult because there's nothing in your own local system again. You put everything in the centralized system. So if maybe any virus go into it or whatever happens to it and is corrupted, that's all. All your code, all your works has gone. So that's the problem with that again. And then we got the third type is distributed version control. Distributed version control is the most sophisticated of them all, of the three, because it allows each local repository to fully mirror the central repository. That what all is in central repository, maybe in the mainframe or the master computer, is also is also available in your own local system. You understand? So, and then everything, including even the issue of how you are modifying, how you are improving on those codes, is both here and there. It's in the mainframe, it's in the central system, and it's in your own local system as well. So this one is the advantage over the former two types of control, because when the central repository is corrupted and the company is just running every day, this code has gone, they can easily come back to maybe you that are QA in your QA team, maybe 2 or 3 of you, they can come to you to your own local system that mirror that central one to retrieve the code back so that they can be able to even pull it back into the central one. Yes, next slide, please, Alex. Benefit, which is benefit of version control. Benefit of version control. Yeah, thank you so much. You see, this version control has benefits in your project management because version control offers a structured, systemic, and reliable way for you to be able to track changes in your project and files, in your project files, rather. And it makes that there are some key benefits that we get from our version control. The first one is that it helps you to maintain version of all files. The latest version of all files that you have, it helps you to maintain it. So with this one, you'll be able to maintain as you are making changes in your codes and every other thing. So it helps you to be able to keep them and maintain them, improve from them, and every other thing. Then the second benefit of this version control is that it helps you to preserve history of changes. Okay, let's say maybe Abimbola or Ugochukwu or whatever, whoever, Jeremiah is the one that say, okay, in this future, I see something that I need to change in my code, in the code. So he went there to go and change it. And then some other person change it, or the QA manager also change it. So the issue of how these things are being changed is there for you to trace. So at every point, you'll be able to trace the changes. Then the next one is that it helps you to facilitate collaboration. Like in your QA team, if one QA1, QAB, QA3, it helps you to bring when you bring your code and when you see the way your code is working, it helps you to learn from each other, collaborate, and pull and push code, either push good codes that will be able to do better than what individual are doing, or somebody that have the better version of the code. So it helps you to collaborate between every one of you to be able to bring about a robust code. Then again, it helps to prevent data loss. So instead of maybe you are keeping it, somebody is in a system, maybe have accident with his own system, and the code is lost, and all the data in the system is lost. So when the other person will have it, or even you go to your central system, you'll be able to pull it back and start working and keep working on it. So the version control helps, or also it helps us to increase transparency and accountability. Like now, when you are giving the assignment, or you are giving the your job, so version control will expose you. There is no room for laziness. There's no room for transit, because as you are logging in and whatever you are doing, when you are pushing it there, it shows there will be time mark on it when you put it there, and then it will make you to be accountable. That way you'll be on your toe, that this is job that you need to do and it's time bound. So you'll be accountable to any assignment that is given to you. And as you are doing it, the time stamp on it will be showing that this person log in this time around and does this one, log in this time around and does it. So version control helps to increase transparency and accountability, which might even cause problem among team members. So version control helps to allay such kind of issue. Then it helps us to simplify code management, because you see all the codes in the central pool. You understand? So you will be able to know, oh no, let's refactor this, let's do that, let's do this one, let's remove this one. As the G was correcting you, so all the things that you are removing out of it is being stored there. So your code will now be able to be well managed. So it will not be scattered every here and there. So it bring the simplicity. It simplify how you are doing it, how that one is being done. Version control brings it as one of the benefit that you are going to enjoy while doing version control. Also, version control helps to identify conflicts. You see, when there is conflict within code, you'll be able to quickly see it. If you are you are using versioning, you are operating on with version control, you'll be able to see this code is conflicting with this one. So let's change this, let's do everything. So because you see everything in the central area, you'll be able to know which one is bringing the conflict within the codes. So can you please help me to go to next slide, please? Popular version control system. Yes, yeah, popular version. Thank you so much, Alex. So now, what are the popular version control systems and tools that is are available for us to use? So these are these are the commonly used one, and the overviews, and we'll be able to at least talk about their pros and cons as well. So we have the first one, which is SVN, which is called Subversion. Subversion is a centralized version control tool. Why it is more advanced than localized version, it has risk because it is centralized. Because if the central repository becomes corrupted, and it is difficult for anyone to retract the change or whatever is there. Then the second one is Team Foundation Server, TFS. Give us the TFS, and it's also a centralized version control system. It's sharing the same limitation as Subversion. Because when coupled with Azure DevOps, however, it can work with Git as well to provide a distributed version control system. And now you can see that this one, because it can work with Git and it can also work with Azure DevOps, then it makes it much more better than Subversion. Because that this one, it makes it you can be able to push and pull from there. Then we have Mercurial. This is open source distributed version control system, and it's better than TFS and Subversion. It's better than Team Foundation Server because it's like it mirror the central repository and history in each repository. Because that means you will be maybe from your own system, what you have in your own system mirror what you have in the central mainframe or the central computer through which you are pushing your code into. So as it is there, it's also in your own local system, which mirror it. So in the case of data loss, people can quickly run to your it's a distributed repository version control system. It is similar to Mercurial. It is very similar to Mercurial. And it comes coupled with GitLab management software and GitHub, the platform to upload copies of repository. So I think now you will be getting to know, at least it's now sounding familiar with us now. You are now knowing that at least if you have not been able to know everything, at least you know Git and you know Azure DevOps and you know GitHub, you know Azure DevOps. So you are now getting familiar with it. So can you please go to the next slide, please? Well, yeah, thank you so much. Now there are three key reasons why version control is to streamline release management. Because it facilitates release management, that is, it helps in maintaining different versions of software that is released. Okay, one of the you will see when you take your phone like this, the application on your phone, you will just discover that your phone will be saying update, update. Why are you updating the app? Because there is another version of codes that have been introduced to either to treat any bug or to improve on the existing codes that are in that application on your phone. So that's the reason why you are updating. You see, you have been doing it. You update all this app on your phone. Even your phone system itself, the software. There will be software update. All those software updates are part of Faro, and if you go to the central system where they are sending it to your phone, you'll be able to trace the steps which day they introduce it. You will see, even okay, let's say again, many of us are using Google Chrome. You will discover that Google Chrome has been updating itself recently from version 118, 119, version 220 now. So it's just introduction of more codes to make the existing code better or to treat some bugs in it. And these are these are the reasons why they are pushing more codes to upgrade the existing one. All these are types and then version control matters because it prevents conflict in code management. So with version control, because everything is there, so it helps the manager or even you that are pushing the code to avoid conflict with your source code base. It helps you to maintain separate branches for different releases. And this one makes you to minimize chance of changing or overlapping, which can cause conflict in codes because you see it everything. So you'll be able to know what to push and what to do. So again, the version control matters because it helps you and I to be able to track the changes in to digital artifacts that we are introducing into our code. So it helps us track changes to different artifacts that are involved in our software development. This may which may also include technical design specifications that are maybe in your PBI that they say, okay, this one, no, we don't like the way this image is looking. Let's look for new image. Let's do you understand? So all these things and any other deliverables that you like to introduce that may be subject to multiple iterations, version control will help you to store and to even be able to trace all this one. So with this, these are the these are the introduction to the version control and to how you push and pull your code in your either in your local repository or in the central repository. So now I will now hand over to my colleagues who will now bring it to you much more pictorial definition and what do we call it, best practices of this version control. And as it's mentioning it, don't worry, if all the we are able, we try as much as possible to not to use high sounding words and technical words so that every one of us will be able to understand it. And I believe that you understand what I've said. So if you see any big words or any more technical words in what you'll be saying, if they are not other big, I will not be, it will come to our level to be so that we'll be able to understand it. So over to you, Alex. Thank you so much.
Yeah, thank you so much, Coyote. Hi, guys. Thank you so much for allowing us to take this session on CICD and version control systems. So Coyote has done a great job at explaining and walking through, why we need version control systems, how they're applied in the software development lifecycle. So we're going to just quickly talk about, I'd like to just quickly share some things with you. Right, so essentially, this is how the process of a version control system, right? So first of all, developers start by creating a repository, which is basically a centralized system where all the code is stored and all the code changes is stored. For example, if a developer is working on his local device, whatever he implements, he will be sent, pushed to a local repository. This could be used via Git and, merged with Azure DevOps where the code will be stored. So you can also make changes. So the developer can make changes to the code base either by adding new code or modifying existing code. Version control systems allows us to, before committing changes, developers can review the changes they have made to ensure that they are correct and they follow coding standards. We can commit these changes. Okay, so once changes have been made to the code base, developers commit those changes to the repository, and a commit is essentially a record of the changes that have been made to the code base. Okay, we also now have the options of merging. So if multiple developers are working on the same code base, they can decide to merge their changes together into a single code base. And I'm going to try and explain this in just a little bit in just a moment. And if the changes are found to be buggy or incorrect, developers can revert to earlier versions of the code base. So essentially, when you think about version control systems, it gives us the ability to collaborate between multiple, developers or multiple contributors working on a single code base. We have a good history tracking of all the changes that have been made to the code base, from the commits. There's all good commit messages. So when you're collaborating with someone on the same feature branch that you're working on, you should be able to have an understanding of what they've done, the changes that they've made. And before any merges are made to the main branch of the code base, it's obviously going to be reviewed to make sure that it follows the correct coding standards before we, merge it into the main code base. So with good history tracking of all the changes that are made to this code base, we can also revert changes. So if I, as a contributor, make a decision or I implement some code that affects the integrity of the code base or introduces some bugs, version control systems allows us to be able to go backwards and revert to the previous version or the previous commit, where we know everything was working completely fine. We can sort of isolate where the problem is. We know where the problem came from, and then we can make some changes. So here's a picture that shows a little bit more about how you have a main branch and how you would essentially work from a feature branch, and then how you would attempt to merge back. So as Coyote mentioned, we have different versions of, you could have different versions of a software, you could have different versions of an application, right? So the version control system allows us to be able to control the changes that are happening to that version. And what happens within that is you would essentially have a main branch. Now let's look at this branch at the top that says main branch, the COC1 that leads to D, E, F. Let's say that this is the main branch. And let's say this is, when we say main branch, let's just say, for example, just this is a very good example. This is the branch that holds our application that the developer is making. So in your teams, everybody's working on a website, everyone's working on a project. Let's say this is the main branch that holds it. So let's say, for example, in CO, maybe we're in sprint 0, right? The developer creates a static website and, he moves on to, sprint 1. Let's say he starts, developing something else. Maybe the landing page is now clickable. Let's say D is an example of maybe, just so on and so forth. Let's just, for the purpose of this example, let's look at all of these little points on the main branch as sprints and things that are implemented during sprints, right? So what you're looking at here is, an example of how if the developer wants to make changes onto the main branch, he wouldn't actually work on the main branch. What he would do is he would create a branch, right? A feature branch that he'll start developing on. And the A, B, and C is an example of when we said earlier, making commits. So you commit changes made to the code base frequently with good commit messages so that you have good track of what you've been doing, and also that, okay, let's say, for example, if you get to C and you're running a test or you're doing something that's not really it's not really good, you can also revert back to B, where your last changes were, as opposed to just working on one single code base, one single file, which is A, and then maybe you introduce a lot of problems to A and it gets a bit tricky, and then you can't really revert back to previous changes. So what would happen at C, essentially, when the developer says, okay, at this stage now, I would like to merge back into the main branch, is a pull request will be created and the code will be reviewed by other contributors that are working on the same code base before the code is approved, and then it's merged back into main. So it's quite complicated. I think the example I use actually doesn't even make any sense to say use this as sprints. But just to let you guys know that, yeah, you have a main branch and you will work on a feature branch, commit changes, and then when those changes have been reviewed and you're happy with them, then they can get merged back into the main branch, okay? So this is another example of a commit, a squash commit, and this is a git rebase. So we're not going to go into some of these and what they mean. Essentially, they're just different types of ways that you can merge your code into the main, right? So we will try and get into that maybe at a later date because it's a bit advanced for now. Okay, so like I said, version control systems are fantastic at encouraging collaboration. We have good history tracking. We have good code. We have code backup. The code has been backed up. It's not stored in our local repository on our laptop. If something happens to our laptop and it gets destroyed, we have the code is backed up in our repository. We can manage the version that we're working on, and it's good for error detection because we can have a look at where the error was introduced and we can try and fix that. Okay, so like I mentioned, developers are able to collaborate on a single code base, making it easier to share ideas and develop code better. So for collaboration, I want you to think about working on a project with multiple developers. So the idea is currently, let's say for the distributed version control system, where everybody can have the entire repository on your local device. It's the same as what we're doing as testers. So we will go on our devices and we'll start making changes. We'll start, writing our test cases. We'll start, doing our automation locally. So in terms of collaboration, how do we get all of the work that all of the developers have been working on? How do we get that into one website? Or how do we get all the test cases that everybody's working on their local devices, and how do we get that, onto to test our website in our repository, right? So essentially it fosters collaboration. We can all work on a single code base and test a single code base, or even work on a single feature branch and be able to, share ideas and develop and test code better, okay? As I mentioned earlier, it allows the developers to keep a complete history of the code base, enabling them to track changes over time, and we can easily revert back to earlier versions if necessary. The code is backed up and accessible in case of data loss on your local. We've already backed it up, so we don't have to worry about that. And also, it enables developers to maintain multiple versions of the code base. And in terms of error detection, we can track bugs and issues to the code base, making it easier to identify and fix errors. Okay, so this is a better example of how collaboration is done using a version control system. As I mentioned before, let's say we have a main branch, our base branch or our main branch where we have all of our code. This is where all of the codes that has been merged into main is. And for example, let's just say this is version 1, we have version 2 here. Okay, great. So this example of how multiple contributors will, they'll clone the master branch and they will maybe be working, they'll switch to a feature branch because you never work on a master branch on your local device, but you would create a branch from the master, and developer A and developer B will essentially be working on their local devices. But what they've both cloned at this stage for version 1 is they're both working on version 1, the first version of that master branch. Okay, and I know this might sound a bit confusing, guys, but it's pretty simple. So as at the time that developer A and B have pulled down from the master, they're working on version 1, right? So they're all going to go and make changes to this code base, as they're working. Well, maybe one guy's working on a login, maybe the other guy is working on sign up. So they're collaborating and they're contributing. And this just shows how they are able to merge their code, back to the main branch after obviously it's been committed, after a pull request has been made, and we can, the code has been reviewed, then they can merge it back to the base branch. And yeah, that's just an example of that, how that happens. So as you can see here, there's an error here where it shows where you can see that developer B was trying to push the code into, trying to push the code without having a sort of downward merge of version 1.1, because at the point the developer B wanted to merge his code back into the main branch after he'd finished developing maybe his sign up feature. The main code base has already changed. So what he needed to do essentially is fetch the latest changes from the master branch before, merging his code here. So it just shows that, for example, let's just say, for example, a code is introduced or something is, happens that is not supposed to happen. It's easy to actually kind of sort of track, where the the error was introduced. So let's say, for example, we know as at the time developer A merged his code into 1.1. The code base was working completely fine. Everything is fantastic. We know that when developer B finishes working on his sign up, and maybe for example he does a downward merge and then he merges it into another version where we now have a sign up feature, and let's say for example that sign up feature then has a bug. We know that that bug was introduced as at the time developer B merged his code into the main code base. So that's just an example of how history tracking, and we can easily have a clear vision of error detection and where the error was introduced into the code base. Okay. All right. So best practice. Okay. The best practice in terms of version control system is to commit small logical changes frequently so that we can provide a clear history of the code base. It's good to have good commit messages as well. So when you're committing any changes, you need to write very descriptive messages that explains to the next person that might be working on the same feature branch exactly what changes were made to the code base as at the time you made a commit. So let's say, for example, it could be something very simple, but the idea of collaboration when you're using version control systems is really so that we all know what's going on. It shouldn't take a rocket scientist or somebody. I don't like, let's say, for example, you're working in an organization and you're in charge of a particular feature, a particular code base, a particular, feature. If you leave that organization, what happens to the code base? It should be so well written and all your commit messages should be so clear and the history tracking should be so clear that another new employee can come back into that same code base and there's a clear, there's a clear history and a clear understanding of what has been made and the changes that have been made to this code base and how we ended up here. Okay, so use branches. As I mentioned before, we wouldn't send you don't ever work on the main code base. The idea of version control is actually to maintain the integrity of the main code base. The main code base is what we are going to deploy into our different staging environments that will eventually end up in the hand of the our end user. Okay, so what we want to do is we want to make sure that as we are committing and making changes to this code base, we are ensuring the integrity of the main code base. So the main branch. So you would never work on the main branch. You would work on a feature branch, and then you would merge, your code when, merge them back when it's ready. Once you're done working on your feature branch. We also review code before any changes are made to the code base. It's very good in terms of having collaboration to have, multiple reviewers, to review the code or changes that are going to be made to the code base. And version control systems provide redundancy and minimizes the risk of data loss or corruption. Okay, so this is just another example. This is the main branch as we have at the top, the blue one, and we can see that, let's say, Coyote was working on a particular feature. He created a feature branch and he has 3 commits that he's made. This is an example of him, committing frequently. These are small changes being made to the code base that he's working on with clear commit messages that explain exactly the changes that were made to his branch. And then as at the time he merges it back into the main, like I said, mentioned earlier, this feature would be a pull request would be created, and you would perhaps sometimes you could have a couple of reviewers or maybe just your test manager, but usually you'd probably have 1 or 2 reviewers, depends on the organization you're working on, and they would review that code before giving it the AOK and merging it back into the main branch. Excellent. So yeah, if changes are not committed frequently, it can be very difficult to track progress. Okay, if you have bad commit messages, it's very unclear and it's very informative and it makes it harder to track changes and understand the history of the code base. If you're not using branches and you're working on the main, failing to use branches can make it harder to develop new features or versions separately from the main code base, and it actually increases the risks of conflicts. I was talking to a friend of mine today. He works in Nigeria, and he was just talking to me about how in his workplace, they don't actually use version control systems. There's no source control, and he's leaving now. So he's got a job. He's going to be going to Malta actually to continue developing. And I was just explaining to him. So how do you track changes? How do you if a bug has been introduced into the main code base, how do you know where it was introduced? And he was like, Alex, honestly, this he said, yeah, he would know because he's the guy that is developing the code. So I said, okay, his name is Sheon. I said, Sheon, what happens when you have a new developer come on board? How is that developer going to be able to figure out the maze of what you've created? And so he was like, yeah, honestly, that's the problem that he's having. But he was saying the company that he was working for, they're trying to cut corners. It's a company in Nigeria. They don't want to pay for licensing of something, and it's really just not the best. It's not the best way to develop. It's not the best way to. It's not best practice, and that's just an example of how it's going to make life a lot difficult for that new developer that's going to be coming in to work for that company. So obviously not reviewing code is great, is really bad. It leads to errors and violations of coding standards, and we can't really, protect the integrity of the code. Anyone can just merge any sort of code into the main code base, and it can be merged with errors. It could be merged with, bad practice and things that shouldn't be there. So that's not a good practice. And then failing to back up a forked repository can result in data loss or corruption if the local system or the local machine or the central repository becomes unavailable. All right. So this is essentially the end of my presentation. We've spoken a lot about version control systems. This particular example that I have is sort of bringing it home to just explain the tester's role in the software development lifecycle and how we may contribute to the version control systems and how we would sort of test, where we test and how our product is released and the different staging environments that we have. Okay, so I'm going to try my best to explain this in a way that we understand. Okay, so what we can see here is we have feature branches. Okay, these features, for example, let's say these are independent features that are being worked on our website. For example, let's on our website. Let's say A perhaps is a login. Let's say B is a sign up. Let's say C is a landing page. Let's say D is a header. Let's say C is a footer. Let's just give them examples. When you see this A, B, C, D, look at them as individual features that we are going to be developing on our website. So as mentioned, we have our main branch, which is where we store our main code. All the merged features will be merged into the main this main sort of develop branch, right? So let's say so what's happening here is we have A, right, that has been worked on. A feature branch was created from the main branch, and developer A, or we worked on this feature, and the feature was worked on. We had our commits, we merged it back into the main, right? We then just said, okay, great, we're going to move on and start working on another feature. So we from this, let's say this is from this same main branch, obviously worked on a different, we created another feature branch to work on B. We worked on that, the developer worked on that, he merged it back into AB, right? And then the developer also says, okay, I'm going to create another feature to work on my sign up for C. He works on his sign up, and then he merges it back into main. As at this point, let's say ABC has now been merged into main, and we are done with our sprint 1 objectives. Let's say sprint 1 was we needed to develop A, B, and C. Okay, we now have our A, B, and C here. So what happens is before this moves into any release branch, right, we would test it. It gets tested. The testers would give their go-ahead on whether or not this meets the criteria. In fact, it would actually be tested from at every single phase. So before Yeah, it'll be tested at every single phase, right? But let's say, for example, we get to A, B, and C, and the developer is done with A, B, and C. The testers will test. Once it meets our definition of done, maybe all our tests are passed, then it would be, pushed out into a release branch, which would be called our version 1. So we have ABC in our version 1 right here. Okay, this version 1 will now be tested it's been tested in the develop sort of environment. Let's say it passes. So this is our version 1.1. Then it got to, different staging environments. You have your UAT, which is user acceptance testing. And then let's say you have your production. However, in your work environment, you could have different names for different staging environments. So let's say this is your develop environment where the developer develops his code and he tests. Maybe at this point, he's doing unit testing or whatever. And let's say it moves into the staging environment, or you might call it the QA environment. So where the testers will now have their, URL as you guys are doing now, and you're testing within that environment. Once it passes that environment, you give your go ahead on that, and then you push it into the next environment. And then once you test within that, let's say, for example, UAT now, once it's tested again in UAT, and it meets your acceptance criteria and you're happy with it, you've done, you move it into main production. So the example that I just want to let you guys understand is the goal of all of this is to develop a product, right? We're developing a product, we're developing a website. So what we have here is a sort of process that allows us to have gates that ensure quality at every stage of a release. So we have different staging environments to make sure that we can test this product that we're delivering to our end users in these different staging environments to make sure that they are up to standards and they meet the requirements that we've developed it for. So you might have your QA environment, then you go into your UAT environment or your pre-production environment, and then you might go into your production environment as well, where the code would be released into production. So yeah, that's just a quick example. We can also look down and see from, so A, B, and C passed the test, right? We're happy with the code that developer has implemented, and it made its way into our production, right? Okay, so then we can see A, B, C, D was now, D was added, a feature D was added. The developer worked on that feature. He merged it into his develop, he merged it into his main in the develop environment. He also added E, right? He also added F. So at this stage, we can see that we know that A, B, and C was good because we tested it. It was tested in UAT, it was tested in all of our different environments, and it's now in master. It's now in production rather, right? And then we at A, B, C, D, E, F, right? We are done with sprint 2. So the developer he's worked on his code in his local environment. He's done his unit testing. He's happy with it. The QAs essentially will test this, right? And we tested it, and we've seen that actually we're not happy with D and E. It doesn't actually meet our criteria. There's bugs, there's bugs. We're not happy with it. So we can't give the go ahead on D and E. So D and E don't actually get merged into our version 1.01. There's some bugs with it. We're not happy with it. So it doesn't meet our criteria. So we sort of cherry pick the features that are ready to go into our next release branch. And then we have our A, B, C, F, right? That now constitute of our version 1.01. And so those features that we didn't give the go ahead on, the good thing is that the developer can still work on that at a later date. But for now, let's just put that in the corner. So A, B, C, D, A, B, C, and F are the features that we're happy with. It meets our definition of done. We've done our testing. We've raised our bugs and our retesting, and then we've tested. We're now that's our version 1.01. We move that into, it gets deployed, right, into our different staging environments. For example, let's say it gets deployed into QA. We test it in our QA environment again. It works well. It gets deployed to our UAT. We test it in our UAT environment. it gets deployed into our production, and that is how we eventually deliver A, B, and A, B, C, and F to our main website. So that's essentially just how the testers are on board. So what we can do now is we can see that with this develop main branch, right? We have a clear history of all of the different commits that have been made, all of the different features that have been made. We know exactly when the developer introduced a feature that was buggy or was faulty. And what did we do? We reverted back to, we were able to revert back to a time where that code wasn't in the code base, right? We can revert back to ABC, where the code base was actually working really fine. And then we can now cherry pick the features that we want to add into our release branch. And then, we add F and say, okay, that feature can go into our, we can add F because it's been given the go ahead, and we can push it. So it's essentially just a great way to track all the changes made to the code base. We can create new features, collaborate with multiple developers, and ensure that we can, maintain the integrity of the code base. Thank you guys for listening. I know that was a lot, but you guys are not really familiar with some of these terms. But as you go along with time, it will start making more sense, because this is actually a big part of what you do as an automation tester. You, as a manual tester, you might be testing manually on your laptop. You might not need to, push and pull any code from the repository onto your local device and start testing it, and then, have your tests on that and then merge it back with the main code. You might not need to do that as a manual tester, but as an automation tester, this is essentially what you're going to be doing at your workplace. Because if not, all of your tests are just going to be sitting on your local device, and it won't really be able to contribute to the growth as the code base is changing every day. You won't be able to contribute to the development of that code base in your wherever your code is being stored. So thank you very much for listening. If you guys have any questions, this would be a good time to ask questions. Me and Kayode will try our best to answer any questions. Thank you. Hello? Is everyone still here?
Yeah, I believe so.
Yes.
Yeah.
Excellent. I know that was a long one. That was a long one. It was a real journey. But do you guys have any questions?
Please don't be afraid. If you don't understand anything, you can. This is the time for you to ask, please. So don't worry, just ask. Yeah.
Can we stop recording and start another one, please? Hello?
Damilola, you know you called in Dami. Hello, Damilola. Let me call him. I'll call him on phone. Stop recording. Yeah, stop recording. Stop recording, yeah. Share the record, Abi. Yeah, stop it now.
Okay, all right. Thank you, guys. So, all right. So, if you can stop recording, then we'll take the questions. Yeah.